Alright, hey, we're going to start with just the basics again. We're going to find complex solutions to polynomial equations, and we're going to find the number of complex zeros of polynomial functions. So complex generally just means there's a lot of them, right? We have x plus 2 and x plus 3 squared here. So we consider this first polynomial, and they've done something really nice in these notes. They've given us the factored form. So what is the difference about the factors if you look at this? Well, we know if we set this equal to 0, let's go ahead and do that. X plus 2 equals 0. We have a root of negative 2, right? So x equals negative 2. That occurs once, right? One time. And if I set this equal to 0, I get x equals negative 3, right? That occurs twice. All right. So, and this introduces something called a multiplicity of a root, right? And multiplicity is just I'm going to use the number sign, number of times that a certain factor, so I'm going to say a factor, occurs. All right. So it can occur once, it can occur twice. We've seen this before when we graphed, right? That one went straight through, that guy bounced at negative 3, that one went through at negative 2, and we've graphed these before. So let's explore different ways to find it, right? So we're going to explore this, and we're going to investigate the relationship between the degree of a polynomial and the number of zeros it has. So we can see that this is a degree of 3, and let's see how many zeros it has. All right, so we're going to go at this and say, hey, you know what, this factors. I see an x squared factors out, which gives me x plus 7, right? And in this case, I have some zeros. I have zeros. I'm going to say p of x here too. And if I set x equal to 0, right, it's solved. This one would be solved. So I'm going to say, hey, 0 occurred, right? 0 had a multiplicity of 2, and negative 7 occurred. So I can see, hey, when this is to the third power, I have 1, 2, 3 roots. All right. Well, what if I come over here and do this guy? Well, we've seen this. That's the difference of cubes. So let's factor this out. P of x equals, and remember the first one is the cube root of this minus the cube root of this. And the next one is this squared, x squared, plus them multiply together 4x plus that squared. Well, we've already got a real 0, and I'm going to introduce the term real 0, right? Because we might see an imaginary number here as well. If I set this equal to 0, if I go x minus 4 equals 0, we know that our real 0 is 4, right? So I have a real 0 of 4. I'm going to just box that right there. We have a real 0 of 4 that we found with this guy. I don't know how to factor this. I don't know anything that multiplies to 16 and adds up to 4. So I'm going to use something we haven't pulled out in a while then. I'm going to use the quadratic formula. 4ac over 2a. So let's go ahead and plug that in. X equals negative 4 plus or minus 4 squared, right? So that's 16 minus 4 times a, which is 1, times c, which is 16, all over 2. And I'm going to give you these answers, right? So I think you all know how to plug stuff into a calculator or do the mental math. So that would be the square root of negative 48 over 2, right? And if I can see that 16 is a factor here, so this breaks up into 16 and negative 3. So if I bring that out, so we say negative 16, so I could also say this is negative 4 plus or minus 4i, rad 3 over 2. And then I notice that both of these are divisible by 2. So this is x equals negative 2 plus or minus, it's hard to see that I in there, 2i rad 3. And these are imaginary zeros. We know they're imaginary because there's an I. It's weird. They're imaginary and irrational because I have a rad 3, but I'm going to list them as imaginary. So I have x equals negative 2 plus or minus 2i rad 3. So once again, I have 2 imaginary and 1 real for a total of 3 when we can see this up here. All right. So I'm going to come here, and look, there's another way to attack this. I think you've seen this before. We're going to attack this with grouping. We'll take our x cubed out, which gives me x plus 3. We'll come here, and it looks like if I take a negative 4x out, I'm also going to get x plus 3. Right? And this isn't working out bad, so I've got x cubed minus 4x over here, and this is x plus 3. You know what I should have done? Look, there was an x in all these, but it's still here, so I'm going to take this x out here. So this gives me x and x squared minus 4. And lo and behold, this looks like you can factor a little bit more. So I'm going to go x and x minus 2 and x plus 2 and x plus 3. And let's call this whole thing px. I think we're factored here. So let's list our zeros. So here's our zeros here. All right, if I set this equal to 0, I get x equals 0. If I set this equal to 0, I get a positive 2. Set this equal to 0, I get a negative 2. If I set this factor equal to 0, I get a negative 3. Once again, these are real zeros. I got 4 real zeros and a 4th degree equation. All right, there's 2 more here. So I'm going to go with it. So let's take this guy right here. And look, it's a difference of squares. So I can take x squared minus 4 and x squared plus 4. And this one's done factoring, but this one looks like it's the difference of squares again. I've shown you a few of these, so I'm going to break that down into x minus 2 and x plus 2. And let's go ahead and bring our x squared plus 4 down. All right? We'll say p of x. All right? So I'm going to let you know that we have real roots. All right? So let's do real. We can see the real roots right here. If I set this equal to 0, I get a 2. If I set this equal to 0, I get a negative 2. And let's play around with this. Let's come over here and set that equal to 0. X squared plus 4 equals 0. I get x squared equals negative 4 if I subtract 4. And if I take the square root, I get x equals positive negative 2i. So once again, we have some imaginary roots there. Imaginary roots. Positive negative 2i. So we can see that we have 2 imaginary, 2 reals for a total of 4 again. And I'm going to show you this guy again. I'm going to show you a trick this, and there's not a lot of space to kind of factor things out, but here we go. My possible roots. And we just went through this. It's called the rational root theorem. And we're going to take all the factors of our constant. That's positive negative 1, 2, 4, and 8. Over all the factors of our leading coefficient. And I've actually graphed this for you. I put this in a calculator. I'm going to show you this in a calculator. There it is. There's that equation. Right? And if I hit graph, it's probably going to tell me. And you can see this. It looks like our factors, our roots are 1 and negative 2. And if you notice that swirl, it looks like it's probably a triple root. But let's go ahead and check it out. We're going to check it out by doing our division, right? Looks like I cross it 1. Let's try 1 out. So if I divide out 1, here we go, synthetic division. I've got 1, 5, 6, negative 4, negative 8. We're just going to check it to see that it is a root. 1 times 1 is 1. 5 plus 1 is 6. 1 times 6 is 6. 6 plus 6 is 12. 1 times 12 is 12. Add them, I get 8. 1 times 8 is 8, and that is definitely a root, right? So I'll list factors and roots over here. Factors, roots, right? So my factor is, well, we see that our root is 1, so our factor is x minus 1, and let's keep going with this. So I'm going to redo this, and I'm going to get my 1, 6, 12, 8, which is what's left of that equation after I factor out that 1. And let's go ahead, again, this group looks like it's a negative 2, so let's try negative 2. And I drop my 1. This times this is negative 2, add to 4. Negative 2 times 4 is negative 8, add once again to 4. Negative 2 times 4 is negative 8, and a 0. So I have another root, in this case, of negative 2, which gives me a factor of x plus 2. Let's go ahead and test this out. Let's take this and we'll write this out and see if we can factor it by hand now. So we've got x squared plus 4x plus 4. And sure enough, that looks like it is a perfect square. Look at perfect square and a perfect square. And if I take the square roots of this, that's x and 2, which is indeed half of that. So this once again factors into x plus 2 squared, which gives me x plus 2 here, twice. I'll write it twice. And it gives me 2 more negative 2's here, or a multiplicity of that. So I'm going to go ahead and I'm going to write this whole factor, but we can see all the roots, right? Negative 2 with a multiplicity of 3, which we could kind of tell from our graph there. And it looks like we have, again, 4 roots when my exponent is 4. But I'm going to go ahead and write this. Let's say p of x is equal to x minus 1, and then x plus 2 cubed, which kind of looked like what the graph looked like, right? Let me put it on there. So I'm going to take a peek at page 2. I think we're starting new stuff. We are, right? Hold on, page 2. There it is. And we're going to fill this out pretty soon. But for right now, and it's going to be filled out, if you'll notice, they're all from this, right? It's all the factors. So I'm going to continue just because this one's already 12 minutes long, and I will talk to you soon.